food and nutritious items is growing, and we got to find ways and means of meeting that demand. So that's the second vertical that we need to concentrate on. The third vertical, and that's where I think it's really closer to the knowledge domain, is to make sure that we realize a fair degree of technology leadership for the country. In an interconnected world, in a globalized economy, and particularly in a country like India, which has a huge market, if we don't have technological leadership, at least in some areas, then we'll be only buyers or exporters of raw materials. And you can't afford to do that for too long. I think we just survived for 5-6 decades. We have to be technologically advanced country so that we can produce products, some new products ahead of anybody else, any other country, and make sure that balance of trade remains in our favor. And it's very important for a country like India, which has a big market. Connected with this is actually a subject where we have to excel in science and technology, convert new research into new technology ahead of anybody else, and so on. And so this is a huge challenge. I don't see many examples of a good piece of Indian research done first time ever and converted into a technology product ahead of anybody even thinking about such a product. Countries have become big on that kind of capability, and we need to acquire that capability. Connected with that, of course, you can't achieve this unless you are extremely good in research, and so you have to be frontline research nation. So I think we need to focus on these three verticals, as I said, which are extremely important for us to move forward as a nation in a manner that is consistent with our aspirations, or rather your aspirations. People who are going to be still around 20 years, 30 years, 50 years, or even longer. And I think the way the earth resources are depleting, this challenge is becoming bigger every day, and sooner we take this problem in our grip, better it is for our country. So there are many dimensions, and energy is just one dimension. Unfortunately, the story is not different in every dimension, but let me now come to the energy dimension. Now, we all know that economy and the energy supply, they are intimately linked. Some of us also know that the quality of life, or the Human Development Index, and energy supply, electricity supply, there is a relationship. Up to a point, for example, on this correlation, see, these are all data points concerning different countries. But that's not important. I can also plot this in terms of data points concerning different states of the country. I can also plot this as data points concerning different cities and towns in Maharashtra. And you will find almost the same kind of correlation. Electricity, per capita electricity consumption, and the Human Development Index. So there is something fairly generic about this. And obviously there are other factors, so there is some degree of scatter. You can draw a curve but within that scatter, I think the central message is clear that in this domain, between this and this, from 0 to 5,000 kilowatt hour per capita, the Human Development Index continuously grows, strong dependence. Beyond 5,000 kilowatt hour per hour, there is hardly any change in the electricity availability and development index. Although the wealth generation per capita GDP will grow even there. So I think it should be a normal aspiration for all Indians to reach somewhere there, to a point where one can expect the best possible human development index, and then do this in a most efficient manner so that we can still grow our economy beyond that while we live within that kind of energy supply. We cannot, well, one would say that why not we look at the possibility of even acquiring higher energy supply. It will be clear to you in a moment that that's not possible. So much of energy sources may not exist on this earth. On the other hand, there are also others who may think that, well, why do we require so much of energy? We are a land of Mahatma Gandhi. So can we not live with less? Well, surely in a limited sense, perhaps you can, but we have to remember we are living in an interdependent world. Aspirations are not dependent on only our limited constrained society. It depends on what we see of others. And so the dynamics represented in this global statistics, I think, is not beatable. You may do this, you may create an environment for a limited period of time. It will be only a matter of time that the human expectations and aspirations will force you to fall in line with this correlation. And so I very strongly believe that we must aim at reaching somewhere there. Mind you, some states are, see, there is a distribution. I told you could have a point here. Each state of India could represent a point. For example, if you see, there is a big disparity in different states. The state of Goa has a per capita electricity supply of around 2,000 kilowatt hour per capita, although Goa does not produce much of electricity by itself. State of Bihar, on the other hand, is perhaps the lowest, maybe 1/20th of that kind of a supply. And we know that the stark reality of this correlation, it straight comes to sort of dawn on us. So, target 5,000 kilowatt hours per capita. It's going to take a long time. We are today at around 780 kilowatt hour per capita. So we are talking about roughly 7-8 times that kind of energy supply in per capita terms. And since our population is not stable, population is still growing, assuming that it will stabilize at around 1.6 billion people, this was a projection some time back, but people now say that maybe it may be more like 1.8 billion people. But assuming it is 1.6, it translates into something equivalent of 8 trillion kilowatt hours of energy supply, which in fact is 10 times the current energy supply. So that is the challenge. We need to be able to produce electricity at a level which is 10 times as large as what we are doing today. Just for you to appreciate this number, how big is this number, the additional electricity that we are talking about, that we should get, it corresponds to 40% of the global electricity supply today. So instead of 5,000, if we say why not have 10,000, we are talking about 80% of the global electricity supply today. Not possible. We'll just disturb the energy dynamics, and of course the sustainability is an issue right today. So that's the base picture on which I want to develop the further logic. Now that's the demand side. We must have that kind of a supply, and I'm not going to the question of when we'll have that. It's going to take time. It's not going to happen in next 5 years. It's not going to happen even in next 10 years. But if it does not happen, then all that we're talking about India's story will be in a serious question. Now, let's look at the supply side, from where we'll get this energy. As far as domestic energy supplies are concerned, you obviously have to consider both the non-renewable or conventional energy sources as well as the renewable energy sources. In the non-renewable category, you could ask that if I were to consume electricity at 5,000 kilowatt hour per capita, or if I were to produce electricity at 8 trillion units annually, how long will a given energy source or resource last? And then you would find that coal, which actually we have one of the largest coal deposits, at the current rate of consumption, we know it may last 100 years or maybe more. But when the energy requirement is 10 times larger, that's going to last only around 10 years. So suddenly a very large energy resource starts looking very small. But we have to prepare for it. The time is not going to be at standstill. It's not going to be waiting for us. This is going to happen. And that's true with almost every other non-renewable source, including uranium, as you can see in that part. And luckily we are endowed with thorium, and that's why we have put so much of importance to thorium in India energy story. Come to renewable energy sources. Again, all these are important. Today, you cannot say that coal is not important. Coal is of course important. That's the mainstay of our electricity supply. So also hydro is important. So also all other renewables are important. But we can ask a question in the context of renewables. You ask a question that if I had to produce 8 trillion units of electricity, what fraction of it can be produced by a given renewable energy source? And you will find that except solar, all other renewable energy sources also appear very small. Again, they are important. All renewable energy sources are very important. We must make full use of all of them. But in the long run, when we reach that kind of large-scale energy use, we have to focus on solar. And so the Indian energy security, I think, very closely depends on thorium and solar energy. I'm not talking about fusion energy at this moment, because for fusion energy to become practical, it may still take around 40, 50 years. And in the context of what I'm talking about, I think that's a bit too long, and so I'm not talking about it. Luckily, both thorium and solar, they are immune in terms of climate change, in terms of they don't emit carbon dioxide. And so this worry that we have in terms of global warming, if we move in the direction of thorium and solar, we not only address the sustainability issue, not only address our ambition to reach a given human development index, but we are also acting consistently with the climate mitigation strategies. Question is, why do we need both? Why not just one? I think the simple answer is, in matter of national energy supply, you have got to have a mix. You can't put all eggs in the same basket. So you need minimum two. If you could have, you should probably need more than two, but that's not possible, but you need minimum two. But over and above that, I think there is significant complementarity between solar energy and nuclear. One is good for bulk generation, centralized generation. One is more distributed source. One is good for operating 24/7 basis. One, you can produce energy only when sun shines. Of course, you can have batteries, you can store and then use it even when sun doesn't shine, but that's a cost, or that's an added technology challenge in terms of making solar energy commercially viable. We have not reached that goal yet. Hopefully we'll reach that tariff parity soon, but so all I'm trying to say, there is that high degree of complementarity between these two sources. Okay, now I'll go through the rest of the thing rather quickly. The situation as of today is something like we are producing in the country around 200,000 megawatts or 200 gigawatts, and the proportion is given there. In terms of our ambition, nuclear is just 2.3%, renewable is 12%, but these are in terms of megawatts, not in terms of the energy produced. Renewable, you don't produce energy 24/7. So this comparison kind of not on the same footing. In terms of energy, the distribution is here, and clearly we need to do a lot of work. This narrow band, nuclear and renewable, has to become comparable with this band, and that is the challenge. So when I became chairman of Atomic Energy Commission, I actually, till that time, the expectation was that nuclear energy is for the future. We must develop technology so that we are ready for future. But on that day, it dawned on me that future is already here. The expectation of the country in terms of delivering megawatts is very large. And so I thought, let's do a detailed study to find out a niche area for atomic energy, because that's the responsibility I was holding at that time. And so we looked at the economic growth projections, and several of them had come at that time, and that's how this BRIC story came out. That's time when it came out that India would become one of the economic superpowers and so on and so forth. So we said, let's look at the economic projections. You can translate those projections into the energy demand, and that's this projected requirement. That's the curve calculated on that basis. And then we said, okay, let's see how can we now meet that requirement. So we made inquiries with different sectors of electricity production and asked them, what are your projections? And we summed them up in an optimistic fashion. No questions asked about whether this will be realized or not realized. And at least to my horror, I realized that after summing up that, including the 3-stage nuclear power program that we had projected in atomic energy at that time, we came up to this point. And so this whole thing was a gap. The question was, how do we bridge that gap? Because if you don't bridge that gap through indigenous sources, it would mean you have to import. You have to import energy. And we know that we are already importing. Even at that time or even now, we are importing fair bit of energy in the form of coal and oil. And you know what's happening to the economy as a result of this large-scale import. And imagine what will happen to our economy if this gap becomes that big. And it was in that context then we said that, look, we can't be just telling that we have this 3-stage program and we are technology development and we'll meet big requirements. And since the limitation of that is as far as the nucleus was on the uranium supply, and so a lot of effort was made, because it's easy to import uranium than to import coal, because the quantity that you need to import becomes maybe 1,000 times smaller. So there is not much issue in terms of transportation infrastructure, the ports, the railway lines, and so on and so forth. A nuclear fuel, you import once, you can also recycle. So you are actually importing energy which can be used again and again, and it's renewable in that sense. It's not true with coal or oil. And so, of course, there was this whole effort which I'm sure all of you have heard, and we have now a possibility of importing uranium. You can set up, the projection made at that time was that you can set up around 40 gigawatts in that time frame. Now, of course, we have lost time. And then on the basis of the spent fuel coming out of these reactors, you can also set up fast breeder reactors, very much the same way as fast breeder reactors one would set up in the 3-stage program of domestic origin. And it came out that you can actually bridge this gap. You can make this country energy independent without having to import anything. So that's one strategy which hopefully will move forward and allow our country to become energy independent and reach its objective of 5,000 kilowatt hour per capita. So we are now, based on the plants which are operating and the plants which are in construction, including all of them put together, so we are pretty certain now that on completion of the projects which are already underway, one would reach 10,000 megawatts. There are also projections, for example, in the 12th plan document, there are these additional reactors which have been provided for, which total to around 17,000 megawatts. So I think even now it's not too late, and we can reach the so-called 20,000 by around 2020 if we act properly, and grow beyond in accordance with the projections which were made. And that requires sites, so there are sites, some work is going on. There is also a lot of public outcry and we need to address that, but I think there is all planning is in place. On the renewable, again the breakup of 25,000 megawatts which I mentioned to you is here, and currently the wind is the biggest player with around 18,000 megawatts, followed by small hydro, followed by bio, and solar is at around 1,000 megawatts. The projections are that they will all grow, particularly the wind and the solar would grow. In fact, solar would become as large as wind by around 2025, 2027, and this is actually happening. The Jawaharlal Nehru National Solar Mission is making very good progress. As I said, the cost is still high. Commercially, it's not competitive, so it's growing on the basis of subsidy. But the good news is that the tariff is coming down compared to the originally planned tariff or the regulator approved tariff. That the bidding process have brought this down in both the first batch as well as in the second batch, and one does expect that we would achieve the grid parity for solar sooner than later, and from that time onwards the growth will be even faster.